Welcome back to the GCSE Maths Pro YouTube channel. Today we're going through the third paper in the November series, so November 2023 paper 3H. This is higher tier and obviously Edexcel. So make sure you have your scientific calculator. As you can see, it is obviously a calculator paper. So let's get into it. The first question is standard form. We've got part A, write 468,000 in standard form. So standard form is always a number between 1 and 10. Obviously not including 10, it's only one digit, so that would be 4.68. That's a number between 1 and 10. And then we just have to figure out, well, how many times we move the decimal place. It was originally here, so 1, 2, 3, 4, 5. So times by 10, and then obviously to the power of 5. It's positive because to get back to the original number, it needs to get bigger, doesn't it? Then we've got write 5.037 times 10 to the power of minus 4 as an ordinary number. So the opposite, but also, do you see how we've got a negative power now? That means the number here, the 5, is actually going to get smaller. So we're going to be moving our decimal place in the opposite direction. I'm just going to rewrite it here, just so we have some space. So here we're going to be going to the left, so 1, 2, 3, 4. Decimal place goes here, and then you fill in obviously a 0 in the front, and then 3 zeros here. The other way you can do it, this only works for the negative powers, is it's effectively you put that many zeros in front. Obviously, there's a decimal place between the first two though. That only works when you've got a negative power, so you can use that logic if you want. So we've got 0.000537. Okay, 2 marks. Question number 2. Here is a biased spinner. The table shows the probabilities that when the spinner is spun, it will land on A, on B, on C, and on D. Luca will spin the spinner 200 times, work out an estimate for the number of times the spinner will land on A. This is really straightforward. All we need to do is take the 200 or whatever number they give you and multiply it by the probability. So in this case it's A, so that's the 0.4. Now remember, this is calculator, so feel free to use that, times 0.4, which is 80. Okay, it's literally as straightforward as that. That's it for the 2 marks. Question number 3, Seja works at a weather station. The table gives information about the temperature, T in obviously Celsius, at midday for each of 50 cities in the UK on Tuesday. Calculate an estimate for the mean temperature. So this is a frequency table. As you can see, it says frequency. It's a frequency table. So the question is, well, the topic is mean from a frequency table. This is actually a really nice question because you just have to memorize the steps and it's the same every time. So we need to create 2 more columns. The first one is for the midpoint MP. And that's obviously the midpoint of these ranges because we can't really do anything with 2 different numbers. We have to have an actual midpoint to use. So 10 to 15, obviously hopefully you can see what the midpoint is, but if you have got something more complicated or you want to actually calculate it, to find the midpoint of anything, you just add them together and then divide by 2. So you can also do that if you prefer. But that's 12.5, 17.5, 22.5, 27.5, and lastly 32.5. Then your next column, we're going to do the frequency multiplied by the midpoint. So frequency multiplied by the midpoint. So this is where you might want to grab your calculator, but 2 times 12.5 is 25. Let's grab the calculator for the next ones. We've got 8 times 17.5, which is 140. Then we've got 13 times 22.5, 22.5. As a decimal is 292.5. 21 times 27.5. 577.5. And lastly, 6 times 32.5, 195. Okay, so you do those 2 columns. Then we have to add up this column here. We need to know the total of the frequency times the midpoint. So obviously grab your calculator. 195 plus 577.5 plus 292.5 plus 140 plus 25. You should get 1,230. Okay, we're on to our last step. So that's the total in terms of the temperatures there, 1,230. And then, just because with mean, we always add everything up and then divide by how many there are, don't we? So we added it all up, dividing by 50, because there's 50 cities. That's your last step. Take your answer, divide by 50. You should get 24.6. Okay, don't round it, just leave that as your answer. 24.6 degrees is the average. Okay, so mean from a frequency table, whether the context is temperature or something else, you always do those steps. So that's quite a nice question if you can memorize it. Now there is also a part B. So Sager says the median temperature is 22.5 degrees because 22.5 is the middle number in the middle group. Is Sager correct? So let's have a look at our table. So she says 22.5 because it's the middle number of the middle group. So she's saying, it's the middle of this one. Now, median is the middle, but this is all distributed differently, isn't it? So what that means is we'd actually want to know, there's 50 cities, the middle city is city number 25, or if you want to do 25.5, that's fine. But we're looking for where does city number 25 lie? Now, if you work out the cumulative frequency, that just means you're adding up every time. You see how 10 to 15 would be 2. If I did 10 to 20, that would be 2 plus 8, which is 10. Obviously, number 25 doesn't fall there. Then 10 to 25 would be 2 plus 8 plus 13, that's 23. 25 doesn't actually lie in that middle group, does it, in this case? Sometimes it does, sometimes it doesn't, it just depends. In this case, it doesn't lie there. City number 25 would therefore be in the group 25 to 30. So that's the reason why you could say she's wrong. So if we come back here, is she correct? Well, no. And then you can kind of almost correct her. You could say, because the middle city, just relate it to the context, city, which is city number 25, is in the group, or the category, whatever you want to call it, 25 to T to 30. And she said it's in the middle group, right? The middle group is 20 to 25. So that's enough of a reason to say why she's wrong. Okay. Question 4. Jenna is asked to show the inequality -3 is less than x, which is less than or equal to 4 on the number line. Here is her answer. Write down 2 mistakes Jenna has made. So the first one, that I think is the most obvious one, is that it's not on the right number. It should be here, shouldn't it? On -3. So you could say the left circle, just reference to which one you're talking about, should be on -3. So that's one side. And then if we look at the other side, it is on 4. However, because it's less than or equal to 4, it should be coloured in, shouldn't it? So you can say the right circle, again, just make sure you reference which one you're talking about, should be filled in or should be coloured in, whatever you want to call it. Yeah. Those are the 2 things, okay? One should be here and the other one should be coloured in. We've also got a part B. Work out the greatest integer that satisfies the inequality. So integer is a whole number, right? So we've got here 5y minus 7 is less than 16. So we need to solve this first. Just think of it as a normal equation. I'm going to move 7 across by adding. Keep the same symbol. So 16 add 7 should be 23. And then divide by 5. You might want to use your calculator for this. 23 divided by 5. Is 4.6, which, as you can see, is not an integer. So they're saying, okay, so we're saying y is something less than 4.6. They're saying what's the greatest integer it could be? So what's the closest whole number? And I don't mean 5, because obviously 5 is too big, isn't it? We're saying that y is less than 4.6. So the nearest whole number... yeah, we can go back to the last one. Hold on. So the nearest whole number would be 4, wouldn't it? It can't be 5, because that's too big. So therefore the closest integer, the closest whole number, is 4. The last question, do you mean this one up here, the inequality one, or the one before that? Just let me know in the comments. This one here is question 4, so I don't know if you mean question 4 or the inequality. Oh yeah, the first one, part A. The bit where it was wrong. This bit where we're trying to find the mistakes, is that the one you want to look at? Yeah, 4A, yeah. Okay, perfect. Yeah, so she's drawn this inequality. Let me rub this out. So we need to show the inequality x is between -3 and 4. It could also be equal to 4. It can't be equal to -3. When you're drawing an inequality on a number line, you always draw the circles on the numbers, as in, so therefore it should be on -3 and it should be on 4. The way that we then show whether it's less than or equal to, whether it's got this equal sign, is whether you leave it empty or you colour it in. So the first mistake was that you have to draw the circles on the numbers, as in, so this circle here, the one that I've drawn, is correct. That's where she should have drawn a circle on -3. So that's why I said the left circle should be on -3, not on -2. So is that first one okay? That's just kind of how you just have to draw the circles on the numbers that are in the inequality. So that's like mistake number 1. It should be left empty as well. It shouldn't be coloured in, so that was fine. And then obviously if I would let me get my straight line. Yeah, where's my straight line? Line. So let's say if I were to draw it above, I'll draw the correct version of what it should be, like if you just asked me to draw it. So you have to draw the circles on the numbers, and then you draw a line between them because it is a range. So that's the first bit. It should be on -3. So the left circle should be on -3. That's the first mistake. It shouldn't be on -2. It should be on -3. The second mistake is then looking at the other side of it, the 4. It is drawn on the 4, so that's correct. But because it's less than or equal to 4, do you see how it's got that extra line? Which means it's less than 4, but it could also equal 4. Therefore, you have to colour it in. So my version is the correct version of that inequality. So if you have a look at, if we compare it, the two problems are that 1, she should have drawn the circle on -3 on the left, and on the right, it's on the right number, but she should have coloured it in because it's also equal to 4. So I said the right circle should be filled in or coloured in, whatever you want to call it. That's just how you draw inequalities on number lines. Does that answer your question? Yep, perfect. Okay. So was part B okay as well? I solved the equation and then I chose the closest whole number that was obviously less than 4.6. If anyone wants me to go over anything again, just let me know. Yes, okay, perfect. All right, so question 5. Ali buys packs of balloons and boxes of pencils. There are 30 balloons in each pack, and there are 24 pencils in each box. Ali buys exactly the same number of balloons and pencils. So we need to work out how many packs of balloons and how many boxes of pencils she could have bought in order to get the same number of balloons and pencils. Now, this one's not very obvious, like they've not mentioned it, but the topic that this is lowest common multiple. Because we're saying, right, you can only buy 30 balloons in every pack. So it's like every 30, 30, 60, 90, so on. And you can only buy pencils in packs of 24. So 24, 48, whatever comes after that. We want to find where those two values, those two numbers overlap, i.e. if you imagine the times tables for 30 and 24, where do they first overlap to have the same number? So this is lowest common multiple, basically. So however you would work out lowest common multiple. Now, you can just list the times tables because it is a calculator, so you could use that to work out the times tables of 24 until you get, both of them have the same number. Or you can use the Venn diagram method. That's the one I tend to use, but it is up to you which method you use. So I'll show you the Venn diagram method. I think it's a bit easier, but especially when you have much bigger numbers that you might not necessarily know the times tables for. So I draw a little Venn diagram there. I break them down into the product of their prime factors. That means factor tree. So 30 I divide by prime factors. Normally I start with 2 just because, well, that's a prime number and it's quite easy to keep halving it until it's odd, and then I obviously go, well, that's 3 and 5. 24, again, I'll start with 2, we get 12, 2 again, we get 6, 2 again, we have to get 3. So we've got 2, 3 and 5, and then 2, 2, 2 and 3. In my Venn diagram, let's say this side is 30, this side is 24. In the middle, you start with the middle. Yeah, so to recognise that it's lowest common multiple, that's quite hard because they've not mentioned it. How did I recognise that? I guess just because I know that I'm going to have to say, well, every 30, so 30, 60, 90, which is the 30 times tables, isn't it? And then every 24, like you can only, in terms of, let's say, packs of balloons, you can only go up in 30s, can't you? You can't buy like half a pack of balloons, so it's every 30, so that's the 30 times tables. And then the boxes of pencils, same thing, you can only buy them in 24, so 24, 48, whatever else comes after that, that's the 24 times tables. So I just kind of and then they said they want to know when they have the same, like they want to have the same number of balloons and pencils, so where they both overlap. I don't know, it's just all those pieces I put together and yeah, this is kind of like both of their times tables, and then I need to find where they both have the same number in their times tables, and then that is literally just the definition of lowest common multiple, isn't it? As in the word multiple. And then the lowest one that they have in common. So this one's not as obvious. There are some that are more obvious, like for example, I don't know if you've seen the ones where it says something like a light flashes like every 30 seconds and then another light flashes every 45 seconds. Work out when they're going to flash at the same time. That's the same thing. Or maybe like trains or buses. It says a train leaves the station every 25 minutes and another train leaves the station every 32 minutes. When are they both going to arrive or leave at the station at the same time? Do you see what I mean? Like they're all the same thing. They're all kind of lowest common multiple, but in a worded way. I do have a video on this actually, on what I call it worded lowest common multiple, because it's, yeah, they've used a lot of context. They've worded it basically. So if you have a look on my profile, there's a video on multiple examples of this. So that might help you to kind of recognize it in the future as well. But yeah, it is kind of hard to figure out what to do if you don't pinpoint what topic it is, I guess. So yeah, I work out the lowest common multiple. So in the overlap, they both have a pair of 2s, don't they? So that's 2. Just put it once for both of those. That represents both of these, right? Then what else do they have in common? They both have 3. So you cross out the 3s. And then whatever's left goes obviously in the left or the right. So we've got a 5 left for 30, and then we've got 2 2s here. And then you just have to remember that the lowest common multiple is all of this Venn diagram multiplied together. All of it. So the lowest common multiple is 5 times 2 times 3 times the other 2 and the other 2. Obviously, I'm going to get my calculator for that. So 5 times 2 times 3 times, doesn't matter which order you multiply them in, obviously, as long as you've got the correct number of numbers. 5 there, yep. That gives me 120. Now, you might have just gone through the times tables and found it more easily. That's fine. If you don't want to use the Venn diagram method, you can just list out the times tables and you probably would have found it quite quickly, but it's up to you. So what we're saying is, this is the number of balloons and the number of pencils. Okay, this is not the packs or the boxes. This is how many balloons. Balloons / pencils. So they can get 120 balloons and pencils. The last thing we need to do is then convert that and say, well, how many packs of balloons is that? And how many boxes of pencils is that? So they say there's 30 in every one of the balloons. If you divide that, you should get 4. So that's 4 packs of balloons. And then 120 divided by 24 for the pencils. I'm pretty sure it gives you 5, but let me check. So that divided by 24, yeah, it's 5. Okay, so don't forget to do that at the end. But however you want to work out lowest common multiple, that's up to you. And then obviously at the end, just make sure you convert it back into packs and boxes. Okay. But yeah, it's kind of disguised, that one, isn't it? You don't really necessarily realize what topic it relates to. Okay, question 6. A company orders a large number of plates from a factory. It would take 30 hours to make all the plates using 4 machines. How many machines are needed to make all the plates in 6 hours? This is another similar question in terms of it's not the same topic, but it's like a worded question. And it's kind of hard to figure out what it relates to. This is actually inverse proportion. Again, what I would call worded inverse proportion, specifically, because it doesn't mention the word inverse proportion. So they're saying it takes 30 hours to make all the plates using 4 machines. How many machines are needed to make all the plates in 6 hours? It's inverse because imagine, if I have fewer machines, it will take me longer to make the same number of plates, won't it? If I have more machines, it will take me less time to make the plates. So see how that's inverse? So I feel like naturally you want to do 30 divided by 4, because we want to work out how long it takes one machine, don't we? One machine, but that's not what we do because it's inverse. If I want to work out how long it would take one machine, I actually need to multiply it. It's going to take 4 times longer because there's 4 times fewer machines, if that makes sense. So it's 30 hours for 4 machines because they're all working at the same time. If I only have one machine, that's going to take 4 times as long, isn't it? Which is 120 hours. So if I've only got one machine, it's going to take me 120 hours to make the same number of plates. Now this one's actually asking how many machines are needed to make all the plates in 6 hours. So then you can divide it. You can say, right, 120 hours is for one machine. If I divide by 6 hours, that would give you 20. So we'd need 20 machines. So this is inverse proportion. It's the opposite of, I feel like, what you'd naturally you'd want to divide first and then times. But actually what we need to do is times first and then divide because it's inverse. This is the same, I've seen it when it says, maybe like painters, like a painter, it takes this long for 5 painters to paint a wall, or it takes this long for 6 builders to build something, you know, how long would it take for 2 builders or whatever? I've also seen it in the context of taps. So you know when they say they're filling a swimming pool and it says it takes this many hours to fill a swimming pool with 5 taps. How long would it take to fill the same swimming pool with like 2 taps, for example? Do you see how they're all different contexts, but it's the same logic. So your answer is 20 there. It's literally 2 calculations, that's it. Sometimes they ask a part B, which is, what assumption did you make? They haven't asked it here, but sometimes they ask that. And you would say your assumption is, we're assuming, and relate it to the context. So in this case, for example, we assumed that all the machines work at the same rate. Or if it was builders, we assume that all the builders build, I guess, at the same rate. Or painters, we assume that all the painters are painting at the same rate. or the taps. We assume that all the taps are like flowing at the same rate, something like that. If they ask that part B question, that's what you put. But they haven't asked it here, so that's fine. Okay, question 7. Riley travelled by car and by aeroplane. He travelled 143 miles by car at an average speed of 55 miles per hour. Riley then travelled for 5 hours and 20 minutes by aeroplane. Work out in hours and minutes Riley's total travelling time. So this is obviously speed, distance, time, isn't it? So you might want your little formula triangle. Speed is distance over time, just so we can rearrange it if we need to. So they want to know the time at the end. We've already got the aeroplane time, so that's fine. So we're focusing on this other sentence. 143 miles is the distance, isn't it? And then at speed, that's obviously speed, 55 miles per hour. So I need to work out the time. So that would be obviously distance divided by speed. 143 miles. They're in, and also check that they are in the same units, as in you see how it's miles and then miles per hour. That's fine. So 143 divided by 55, obviously on my calculator. Divided by 55 gives me 2.6. Now that's in hours, isn't it? Because they said speed was miles per hour. So that's hours. Once we've done that, then it's just basically asking us to convert them, because you see how they want it in hours and minutes. This is just hours. So I need to know how many, obviously it's 2 hours, but what is 0.6 in terms of minutes? So what you can do, obviously take away the 2, because we know that that's 2 hours, don't we? 0.6, if you want to convert hours into minutes, you obviously times by 60. That would be 36 minutes. So that's 2 hours and 36 minutes for the car. And then we would have to add the 5 hours and 20 minutes of the plane. So obviously the hours is 7, and then the minutes, 20 plus 36 is 56. Obviously make sure that doesn't go over an hour. It doesn't. Okay, so that's just a bit of speed, distance, time, and then just converting hours into minutes. Okay, question 8. The diagram shows a solid cube placed on a horizontal table. We've been given, obviously, I don't know if you know this, you don't need to memorize the pressure, force, area formula because they will give it to you. The one you do need to memorize is density, mass, volume. That one they don't give to you for whatever reason. So they've given us this. Obviously you can put it into a formula triangle if we need to rearrange in the end. So the pressure on the table due to the cube is 3.5 newtons per centimetre squared. So we've got pressure. The force exerted by the cube on the table is 504 newtons. See how those units also match. So that's good. So we've got pressure and we've got force. They've then said show that the total surface area of the cube is less than 900 centimetres squared. So the area here is just referring to the bit that's touching the table. So that's just one of the sides of the cube. That's what the area is saying. So if I've got pressure and force, I could use that to work out the area, couldn't I? So the area is the force divided by the pressure, which is 3.5. Obviously, type that in. Oh, not 305, 305. Go back, make sure you obviously type it in properly. So that's 144. Now that's in terms of centimetres squared, because they've told us there. But that's not the final answer, okay? That is just the area of one face. The surface area of a cube is all of those faces added together. Because it's a cube, obviously all of the faces are the same. So each of them is 144 centimetres squared, and there's 6 of them, aren't there? 6 faces. So the surface area would be 144 times 6. So just don't forget to do that last bit there. 864. Now that makes a bit more sense. You see how they said show that it's less than 900? If you only got 144, that's so far less than 900 that it seems like surely that's not the final answer. So yeah, you had to times it by 6. And then I think you had to put a little conclusion, like not worded as such. I think I would probably just write, well, 864 is clearly less than 900. Like, that's my conclusion. Show that it's less. Well, yeah, it is less, isn't it? 800 is obviously less than 900. So yeah, that's that one. Just be careful because there are 2 steps there between the difference between area and surface area. And let me scroll down so you can see how many marks that was. 3 marks. Okay, question 9. The line L is shown on the grid. Find an equation for the line. So yeah, really nice question, this one. Straight lines are always in the format, it might be rearranged, but this is the basic format, isn't it? Of y equals mx plus c. So we need to know m and we need to know c. Normally I do the gradient first. In like 9 times out of 10 I would work out the gradient, which is the m. The only reason why I would say you could do the plus c first is because we can physically see it. That's the y-intercept, isn't it? So yeah, normally I do the gradient first, but in this case I can see what the y-intercept is. It's 3, isn't it? Plus 3. So I've already got y equals mx, and instead of plus c, I can write plus 3. Sometimes if it's negative, just put minus, don't put plus minus, just put literally minus. Now I need to know the gradient. The gradient is the change in y over change in x. You might just want to draw a little triangle. So choose 2, when I say solid coordinates, I mean like whole ones. Don't choose like this one, for example, because I mean, I know it's halfway, but you don't necessarily know if it is. So for example, I'm probably going to choose this one here, which is, oh, I'm going too far, 0, 3. And you could choose 1, 1. You could choose this one up here. You could choose this one. Like, you could choose any as long as you've got 2. Okay, any of those is fine. Let's go with 1, 1. You can also obviously draw a triangle if you prefer to do it that way. I tend to do it this way just because when I don't see the graph, which is most of the time, when they just give me coordinates, at least I know what to do. So change in y, 3 minus 1, over the change in x, and just make sure it doesn't matter which of the 2 coordinates you put first, as long as you match it. So you see how I started with the 3? So therefore I would have to put 0 for the, you see how like vertically that's the same coordinate, isn't it? And then the other one. Just so you get the correct symbol. So 3 minus 1 is, I mean, you can obviously type this in your calculator if you want, but 3 minus 1 is 2. 0 minus 1 is actually minus 1. So you see how you'd get minus 2. Be really careful. I mean, you can see it's going down as well anyway, can't you? The other way you can do it is see, that's 1 across, minus 2 down. Whichever way you want to do it. There's loads of different ways. So that's the gradient. So my answer is y equals minus 2x plus 3. That's your final answer. Equation of a straight line is really straightforward. Again, obviously, as long as you've memorized how to do it. There you go, another nice 3 marks there. Okay, question 10, make m the subject of k equals p plus 2m over 5. So I normally try, and if there's anything added or subtracted, I try and move that across first, like the p I'm just going to move across. So I'm going to take it away. Obviously do the opposite of what's currently there. And then we want to deal with the fractions, so you have to do the denominator first. Multiply by 5. You can expand this if you want, or you can leave it like this. Doesn't matter. 2m, and then obviously then divide by 2. So I'm going to leave it with the brackets just because I don't really want to have to expand it. There you go. That's it. So m is, obviously we're trying to make m the subject, right? We're trying to get m on its own. M is 5 multiplied by k minus p over 2. Okay, question 11. The floor plan of a house is drawn using a scale of 1 to 50. So whatever, it's basically, yeah, so whatever's on your drawing is 1 would be 50 in real life. Okay? Would be 50 like times that in real life. So on the floor plan, a room in the house has a floor area of 48 centimeters squared. Work out the real area of the floor. So, and they also want it in meters squared as well. We have to do a conversion at the end. The first thing is that the scale is based on like one-dimensional measurements. What I mean by that is, if I got let's get like a rectangle. The 1 to 50 is based on one dimension, as in, you see how it's one side, or this side. That's just one dimension. They've given us the area in terms of 2D. So that's already the first thing that doesn't match, basically. So what we're going to have to do is, if I write 1 to 50, that's one dimension, right? That's one, like a side length. So the length of a room, rather than the area. If I want to make that 2D, how do you go from one dimension to 2 dimensions? Well, you obviously square, don't you? I mean, you can see that, squared. So 1 squared is still 1, but then you'd have to do 50 squared, which you might know, or you can obviously look it up with the calculator. It's 2,500. So this is now the ratio for the area, because the first one was not the ratio for the area. It was the ratio for like the lengths of the room. So now it's 2D. Now I can compare that to my actual area they've given me here. Now, this is on the plan, so this is on the left side, isn't it? 48, and then how do I go? I'm just looking at this bit now. If I've got 1 to 2,500 and then 48 to what? Well, obviously I'd have to multiply 2,500 and 48, wouldn't I? So 2,500, that's just ratio. So times that by 48 is 120,000. 1, 2, 120, and then 1,000. Now, the 48 was centimetres squared, wasn't it? So the 120,000 is also centimetres squared. So that's the real area of the room, but they wanted their answer in meters squared. So we've also now got to convert that. You can forget about the ratio now. Now we've got to convert that. This is one of the conversions they're expecting you to know, as in centimeters squared into meters squared. So I would just memorize it if you can. But if you've not memorized it, the way I kind of figure it out is, well, imagine that was actually a square. Let me get a square. Yeah, that's a square. If I copy that, exactly the same square, right? Let's say that that is 1 meter by 1 meter. The area is 1 times 1, which is 1. And now the exact same square, what is 1 meter in centimeters? Let's move this over a bit. 1 meter in centimeters, which we obviously should also know, is 100. So see how that would actually be if I were to convert it originally 100 by 100. So then the area, if you multiply those together, is 10,000. Do you see how? But they're the same square. So what I'm saying is 1 meter squared is the same as 10,000 centimeters squared. You can just memorize those numbers, obviously, but if you need to figure it out in the exam, if you've forgotten, that's how I would work it out. So to convert it into meters squared, obviously it's going to be a smaller number, so I need to divide 120,000 divided by 10,000. 10,000 is 12. Okay? So it's these little details we need to check as well. It's actually, we want it in meters squared. You can see all that, yeah. Okay, question 12. The diagram shows a shaded sector POQ of a circle with centre O and radius 6.2. The area of the shaded sector is 82.6 centimeters squared. Calculate the size of an angle X. Okay, this is really straightforward as long as we've got the formula. So formula for the area of a sector is the area of a triangle, is the area of a circle, which is obviously pi r squared, but it's a smaller portion of a circle, isn't it? So then you multiply that by what portion of the circle is it? Well, that's the angle, put theta, divided by 360, because obviously this whole thing would be 360, wouldn't it? That would create you a fraction of the whole circle. So that's the area of a sector formula. Now, we can just sub in all these numbers that we've been given. So we know the radius, don't we, is 6.2. So that's squared times by pi. Now the angle, we don't know, it's x. So I'm going to put x there over 360. And then we know that that equals to 82.6. So do you see how I've now got an equation? And the only thing I don't know is x. And luckily, the only thing I want to know is x. So once you've done this, you can almost forget about the context and just go, well, this is just solving equations. So what we can do is I'm going to divide across by this. Obviously on my calculator. You could do it all in one step, but I'll show you in two. So as in, I need to divide by pi times 6.2 squared on both sides. Obviously on the left it would disappear, it would cancel out. And on the right, 82.6 divided, I'm going to put it in a bracket, by pi times 6.2 squared. Obviously not a great number, but write down a few of those decimals. So 0.6839 ... Don't lose the number in your calculator though, leave it there. And then you see how the last thing I need to do is multiply by 360. So my calculator, I'm going to take that answer and just directly times it by 360. Don't round it too soon, okay? Never round anything too soon if you can avoid it. 246.234 ... Was it 246? Yeah, 246.23 I think it was. Yeah, anyway. So that's the angle. Now just double check obviously what they want you to round it to. They've said give your answer correct to 3 significant figures. So that's the 2, the 4 and the 6. And I don't need to round up because obviously the next number is 2. And just think, does my number kind of make sense? Like if you look at that angle, I know it's not drawn to scale, but if you just look at it, it's obviously bigger than 180, isn't it? Obviously it must be smaller than 360, but it looks like it's bigger than 180, so that makes sense. Okay, question 13, cumulative frequency. So Alan grew 80 plants of the same type outside. The cumulative frequency graph shows information about the heights in centimeters of these plants. So you can see it obviously goes up to 80, and then we've got heights between 0 and 125. One of the plants is chosen at random. Find an estimate for the probability that this plant will have a height greater than 90 centimeters. So for example, like for now, just ignore the fact that we're saying probability. Don't worry about that just for now. I want to know how many plants have a height greater than 90 centimeters. That's obviously the x-axis, isn't it? So get your ruler and draw a line at 90. Now, this one's actually quite hard. The scale's quite hard here, isn't it? I guess that's how they've made it harder. They just made a really difficult scale. So we've got 10 squares, which represents 25 centimeters, doesn't it? So each square is 2.5 centimeters. So this one will be 77.5, 80, 82.5, 85, 87.5, 90. This one here. Where's my pen? The one next to that halfway mark. Make sure I've got that right. Yeah, that's 90. Okay, so just be really careful of the scale. That's actually the hardest bit. So I'm going to draw a line up from 90 till it hits my curve. You see it's luckily exactly on a point there. And then across, because the number of plants is on the y-axis. So there. Again, just double check your scale. So this one's a bit more straightforward. That's obviously 70, isn't it? So that would be 72, 74. Now, the other thing to bear in mind, and this pretty much always happens actually, is that they want a height greater than 90. So your answer is not 74, because 74 plants have a height less than 90. That's all below 90, isn't it? That's representing this part of the curve, which is below 90. What we want is this part. So do you see how obviously we know the total is 80? That would be the difference between 74 and 80, which is obviously 6. So just double check, have they asked me for something over, which I think they often do. Meant to be at 4. So first of all, we've worked out how many plants are over 90 centimeters. There's 6. That's 6 plants. Now just come back to what they were asking about a probability. So if they've chosen one plant at random, they've chosen that plant out of the 80 plants that there are. So to make it a probability, you literally just have to divide 6 out of 80. Like the probability bit's the really straightforward bit. You've got, how many chances do I have to get a plant bigger than 90? Well, 6 chances out of 80 chances out of 80 plants, isn't it? You don't even need to simplify it, but you can if you want. Okay, that's part A. Part B is then just use the graph to find an estimate for the median height. You know how to do this because there's only 1 mark. So we were talking about median before. Median is the middle number, in this case the middle plant. So if there's 80 plants, the middle plant is number 40, isn't it? So this time we're going from the cumulative frequency axis, because frequency is the number of plants, isn't it? So when you're doing the median, you always come across from the y-axis at 40 in this case, and then obviously down, because I want to read it off in centimetres. There's the median. So just be careful of your scale again. Remember, each one is 2.5, so that's 52.5, 55, 57.5, 60. Okay? So the median in centimetres is 60. Now, they did give you a range of possible answers you could get, but I think that one's fairly clear. As long as you got anywhere between, they said 58.5 to 61.5, because I guess if your ruler line isn't that accurate, as long as you get something between those two values, it's fine, but the actual, like, the official answer is 60. So you can mark yours based on whatever you got. Now there is a part C and a part D. Also use the graph to find an estimate for the interquartile range. Okay, if you can do the median, you can do the interquartile range. So come back to our graph. First of all, interquartile range is the upper quartile minus the lower quartile. So we need to work out both of those values. Now, we said the median is the middle. That's like 50%, isn't it? Or a half. The upper quartile is therefore 75%, or 3/4, whatever you want to use. And the lower quartile is 25%, or 1/4. And that's all of the total number of plants. So we need to know what is 1/4 of 80. Well, obviously 80 divided by 4 is 20, or it's half the median, isn't it? So for the lower quartile, I'm going to go across at 20. Obviously try and draw that better, but you can see it's on that point there, isn't it? There. So, right, that one's 27.5, 30, 32, 35, 37.5, 40. Yeah, so that's the lower quartile. And then the upper quartile is 75%, or 3/4. So if 1/4 is 20, then 3/4 is obviously 60, isn't it? Times it by 3. So exactly the same thing again across. Luckily this one's on an exact number there. That's, I mean, obviously 75. So our interquartile range, we then actually have to do the subtract, right? You have to subtract it. So 75 minus 40 is 35. And that one's the upper quartile there. So just be aware with cumulative frequency, am I going from the x-axis up and across, or am I going from the y-axis across and down? Because there's those two types of questions. So that was, what was it, 75 minus 40. Obviously don't rub out anything on the graph, because they will use that to mark you as well. Okay. Now there's a part D. So the previous one was about plants that he grew outside. Okay, so in that context, Alan also grew plants of the same type, but inside now. The interquartile range of the heights of these plants is 30. We've just worked out the interquartile range of the heights of the plants outside. This is now the interquartile range of the plants inside. So give one comparison between the distribution of the heights of the plants grown inside with the distribution of the heights of the plants grown outside. Okay, whenever they ask you about comparing distribution, normally it's a 2-mark question. Here they've only said give 1, so that's why it's 1 mark. Normally, if they ask you that, and this can also work for box plots as well, you mention the medians of both and then the interquartile ranges of both. You just, when it says compare, literally compare it. Like, the median of this one is higher than the median of that one, or the median of that one is smaller or lower or whatever. The interquartile range is bigger or smaller or whatever. Literally just do a comparison. You don't need to analyze it. So those are the two things you normally say. In this case, they've only said give one. And given that I don't know the median of the inside plants, I'm obviously going to have to comment on the interquartile ranges, aren't I? So basically they're saying just compare the interquartile ranges. It seems too basic, but I literally want you to just say which one's bigger or which one's smaller. Like, that's literally it. So it's not going to let me type it, I don't think, but relate it to the context though. Use the words of the context that they've given you. So I would say the interquartile range, you don't have to write the whole word, just put it like that, of the heights, so I'm using the context of, you say the plants inside, I just called them inside plants because I feel like they're going to understand what I'm saying, of inside plants, and then in brackets you can write down the data, is less or is smaller, or, you know, some synonym of that is less than, and then do the same with the other one, interquartile range of the heights, oh, if I could spell height, that would be great, of outside plants, and then in brackets, that one's 35, isn't it? Make sure you obviously get the numbers correct. That's it. I know that doesn't seem to explain anything, but they haven't asked you to explain anything. They just said compare it. The other option they gave, which I thought was interesting from the mark scheme, is they said the heights of the plants outside are more varied. So you could mention that word if you feel happy to use that word. Or the heights of the plants inside are less varied. But you're basically just comparing the numbers, which one's bigger, which one's smaller. That's literally it. And as I said, I didn't mention the median here because I didn't know the median of the inside, so I couldn't compare the medians. Okay, question 14. Here are the first six terms of a quadratic sequence. Find an expression in terms of n for the nth term. This is another really nice one if you've memorized the method, because it's the same method every time. So make sure you memorize it. I think there's different ways to do it actually, but I'll show you the way that I learned how to do it. You want to work out the first difference. So I don't know why they're giving us so many numbers, but anyway. So the difference here is obviously 6. This one is then 10. This is 14, so on. Work out the differences. You probably don't even need to do all of them, just the first 2 or 3. Yeah, the first 3 I would say. What's that? That's 18. And that's 22. Now, the first difference won't be the same number, that's fine, because it's not a linear one, is it? It's quadratic. So then you work out the second difference, as in the difference between 6 and 10 is 4. 10 and 14 is 4. 4 again, so on. This one, the second difference, should be the same number. If you've got a different number, something's gone wrong. That's the first bit. Then these are the 3 things you need to memorize from my method. As long as you memorize them, you're fine. We're looking at the second difference first. You have to start here. That one is always equal to 2a. But you just memorize 2a. 2a is equal to this second difference. In this case, the second difference is 4. Do you see how I can solve that equation now? I could divide by 2. A is 2. So that's one of the things you need to memorize. 2a. Then what you do is you jump on this left-hand side. It has to be on this left-hand side. Jump back up. The first difference, but it has to be the first one. Okay, it can't be the second one over here, 10. It can't be 14. It has to be this first one. Is equal to 3a plus b. So you need to memorize that. And you see, because we know what a is, if I sub in a as 2, now you can solve for b. Obviously that's 6 plus b is 6, which you'll probably see what that was going to be. That's obviously 0 then, isn't it? I get my different highlighter. That's that one. There. So that's the second one you need to memorize. And then you jump up again on this left-hand side to the first term in the actual sequence. It has to be the first term. That one is equal to a plus b plus c. Do you see how I have to do it in this order? Because I obviously need to know what a is in order to work out b, and I need to know what b is in order to work out c. So A is 2, B is 0. And then you could work out C. So that one is always equal to A plus B plus C. So as long as you memorize 2A, 3A plus B, and A plus B plus C, you've got your answer. Now, A and B and C relate to quadratics. You know when you've got a quadratic, it's always an squared plus bn plus c. That's what these are. So that would be 2n squared. Because b is 0, there's no, in this case, there's no n in the middle. And then you've got c is 3, so plus 3. That's it. If you memorize that method, it's the exact same every time. Super easy. Just have to obviously make sure you memorized it accurately. I guess that's why it's only 2 marks. Okay, question 15. This one was actually, I mean, it's only 2 marks, but I thought it was kind of tricky to figure out. So the diagram shows triangle ABC. Pay attention to which way they've mentioned the sides. A to B up here and then C. And triangle AED. Do you see how that's A down here to E and then up to D? They've done that, I think, deliberately. I feel like normally they do ABC and ADE in the same order, but they haven't, so just bear that in mind. We need to show that triangle ABC and triangle AED are similar. So similar shapes or similar triangles means they're exactly the same, except one is just a bigger version of the other, as in all the angles are the same, but it's, imagine you've just kind of clicked one of the corners and dragged it bigger. So it's all the same, like it's the exact same triangle, just a bigger version, right? There's a scale factor. So we need to show that they're similar. We need to show, therefore, that they have the same scale factor. Now the problem is, you probably also notice, even though these two sides match up, you see this one and then this one, they're obviously not parallel, are they? So that's why they've mentioned it the wrong way round, because they've overlapped the two circles, the two triangles, but not in the same corners. Like they've rotated one of them. I don't know if I'm explaining that very well. They don't overlap exactly. Like if I dragged corner E to corner C, it wouldn't obviously be this. It would be a different triangle, wouldn't it? As in, it's rotated. It's not the same. So when you try and find a scale factor, you normally have the side length of one of the triangles divided by the side length of the other triangle. But it has to be the same, like the matching side length, doesn't it? In this case, we have to pay attention to which way round they've said. A to B first and A to D. So what I mean by that is, they're saying that this side here, AB, is actually the same in terms of if you apply a scale factor as AE, not as AD. And then you could, I guess, look at it vice versa. The side AC is then the same as AD. So it's not quite as straightforward as normal, just, oh yeah, just work out the scale factor from the matching pair. You have to figure out what the matching pairs are. So I would add together both just to find the whole size of AC and the whole size of AB. You could start with that anyway, even if you're not really sure what to do. That one's 32 plus 22, just to find the whole length, which is obviously 54. And then that one is compared with AE, 21.6. So you can work out the scale factor by dividing them whichever way round you like. I personally prefer to divide the bigger by the smaller, just so I at least have a number bigger than 1. That's just my own preference, you don't have to. You could divide it the other way around if you want. So, the scale factor between those, 54 over 21.6, 5 over 2, or in other words, 2.5. That's your scale factor. To prove they're similar, I want to show that I also have the same scale factor. That was for the green, wasn't it? I want to show I've got the same scale factor for the blue sides. So that was green. Do the exact same for the blue. So obviously first I'm going to add them to get the whole of what was it, AC? Yep. 21.6 plus 58.4. Obviously put that in the calculator, but it gives you 80. So then I'm going to do the scale factor in the same way, as in I'm going to divide it, the bigger by the smaller. That one matches with AD, which is 32. So I'm going to do 80, hang on, scale factor, 80 divided by 32. So do it in the same way, you know, the bigger by the smaller or the smaller by the bigger, whichever one you decided is fine. So 80 divided by 32. Do you see how I get the same scale factor? That's what's going to prove that they are similar, that you've multiplied effectively all the sides by the same scale factor. Obviously we can't test out the other side because we don't know what it is. That's fine. So I think again you need some kind of, I mean it's only 2 marks, but I think maybe a little conclusion. Show that the two scale factors are the same. I guess I would assume that's implied, but if you wanted to, you could put it in a ratio. AED to ABC. Obviously put the smaller one as 1. And ABC has just been multiplied by 2.5, hasn't it? If you divide it the other way around, then put 1 on the bigger one and then your scale factor on the smaller one. I don't know. You could put like therefore. I like to do little 3 dots, therefore similar. Again, you don't need to write anything like actual sentences. I think that would be fine. It's only 2 marks ultimately. But yeah, it was only confusing because you had to figure out which sides were actually similar, which sides matched each other. That was the bit that I thought was quite hard. Okay, question 16. So Zia has to set a 4-digit security passcode on her phone. Each digit of the passcode is a number from 1 to 9. She can use each number more than once. Zia tells her friend Amber that the first digit is a cube number, the second one is prime, the third one is greater than 6, and the fourth is an odd number. The diagram shows one possible 4-digit passcode. Amber is going to have one attempt at guessing Zia's passcode. Work out the probability that Amber guesses Zia's passcode on the first attempt. Okay, so it says probability, but again, ignore the probability for now. That will be like the last bit. The actual topic that this is, and I feel like I don't know if you've seen this recently, or if you even know the name of it, but it's called product, which means times, rule for counting. I've got a video on this separately if you want to go through it as well. Product rule for counting. It's when you've got like loads of different combinations. It could be in terms of a passcode. It could be in terms of like, you know, it says there's this many starters, this many main courses, this many desserts. How many possible combinations? Like maybe this many trousers, this many tops, this many pairs of shoes. How many combinations of outfits? Like that's the topic. It tends to have a different context every time, but this is the same topic. So what I'm going to do is, first of all, in this list, I'm going to list out the numbers that it could be, as in the first digit is a cube number, obviously between 1 and 9, right? So that's only 1 and 8. Those are the only cube numbers, aren't they? Then the second digit is a prime number. So what prime numbers are there between 1 and 9? 1 is not a prime number. So 2, 3, 5, and 7. 9 is not a prime number. Then the third digit is greater than 6, so that would be 7, 8, or 9. And the fourth digit is an odd number, so 1, 3, 5, 7, 9. Now, product rule, as I said, means multiply. And for counting, we're counting them, how many combinations there are, basically. So you basically take, of every category, whatever the context is, whatever category you've got, you multiply that, however many you've got, each time. So what I mean by that is the first category is, in this context, is obviously our first digit. How many options do I have? I've got 2. And then I would multiply that by how many options I have in my second category, which is this case is the second digit, 1, 2, 3, 4. And then I'd multiply that by my third category. In this case, I've got more than 2 categories, 3 options. And I'd multiply that by my fourth category, which is 5 options. That will tell me. And she says she can use the same number more than once, so that's fine. If I multiply all of those, it will tell me how many possible combinations there are of her passcode. So 2 times 4 times 3 times 5. There's 120 different possible combinations or different possible passcodes. So we've got 120. And then we go back to now you can worry about the probability. So Amber is going to have one attempt at guessing Zia's passcode. What's the probability she gets it? Well, Zia's only got one passcode, but there are 120 different possibilities. So Amber's only got one chance out of 120 to get it right. Because there's only one correct passcode out of 120, isn't there? So that's the probability. Again, I think there's different ways to do it, but that's how I do it. I use product rule for counting, and then I just convert it into a probability at the end. 3 marks. I'm not sure if there's a vectors question on this paper. Maybe there was. Just check. No, that's circle theorems. No, I don't think there's vectors on this paper. Maybe it was on the paper too. I think there was vectors on the paper too, which we went through yesterday, which is, you can have a look on my channel if you want to see that one. I also have my own videos on vectors as well if you want to look at some more. And that's fine. Okay, question 17. We have got write x squared minus 8x plus 3 in the form x minus a squared minus b, where a and b are integers. Okay, it doesn't say it, but you should recognize this format as completing the square. So we just need to know how to complete the square. Basically what we do, the first thing is you write this format with the x and then the squared brackets. You copy the same symbol that's in front of this one, so that's minus, and then you half the coefficient of x, which is then 4. So finding out a is quite easy. Then what you need to do is you always subtract, it doesn't matter what symbol this is, you always subtract this number squared. Okay, which is technically minus 4 squared. And then you also don't forget you've got the plus 3. And obviously now you just need to work out this bit. Okay, so minus 4 squared, be careful in your calculator. Minus 4 squared is positive 16, so be careful if your calculator gives you negative 16. But because I'm subtracting it, minus 4 squared minus positive 16 plus 3. So overall, obviously that would be minus 13, wouldn't it? X minus 4 squared minus 13. So that's a and b. Extended maths for Edexcel. Do you mean like IGCSE Edexcel? Or what do you mean by extended? This is just a normal GCSE, as in not IGCSE this one. This one's just the normal GCSE. It is higher tier, but it's the normal GCSE paper, not the IGCSE one. Vectors and bounds. Definitely seen bounds recently. I don't know if it was on this paper or the last one we did. Might have been on. Oh no, yeah, bounds is on. We've got a question on bounds. It's question 22, so we'll be doing that once I get through the next few questions. As well. And I've also got videos independently on bounds, upper and lower bounds, if you want to have a look at those on my channel. After we finish this live, I'll link everything. All these topics that are on this paper, I'll link them all in the description so you can come back and have a look at my other videos that obviously go through more questions on each. Okay, part II hence, so that means like therefore, so using your answer from part A, write down the coordinates of the turning point of the graph. Now this is obviously a quadratic graph, right, which is a U shape, so that's the turning point. This is another one, it's super easy, you just have to memorize it. Obviously, turning point has 2 coordinates, 2 numbers. There are only 2 numbers here. Now, the only thing you need to remember is, okay, the one that's in the brackets with the x is the x coordinate, but you have to remember to change the symbol. So that's currently negative. I need to write down positive 4. Just remember that. You have to change it. And then the one that's on the outside is the y coordinate. Now, you don't need to change it. Just keep it as it is. If it's positive, keep it positive. If it's negative, keep it negative. So those are the turning point coordinates. That's really easy if you just remember how to do that. If you want to know why, it's relating to graph transformations, so just look into that, you know, in you've got -4, that was actually, well, as in that's actually add 4, isn't it, which is that way, and then -13 is, anyway, I'm not going to go into it, but it's basically relating to graph transformations, which is why it works, but you don't necessarily need to know why. Okay, part B. Solve 7x squared plus 8x minus 5 equals 0. Give your solutions correct to 3 significant figures. Now I feel like your first step for solving quadratics like this is normally factorizing, normally. But do you see how they've told me? Give your solutions correct to 3 significant figures. That tells me they're going to be a load of decimals, which tells me it's probably going to be very hard, if not impossible, to factorize. So I'm not even going to bother factorizing. And given that this is obviously a calculator, I'm going to use quadratic formula, which is on your formula sheet. So it's on your formula sheet, but it's basically x is minus b plus or minus the square root of b squared minus 4ac, to be really careful with any negatives here, over 2a. That's what I mean. It's on your formula sheet. And do you remember we just did quadratic nth term? A, b, c are the same things in order. So a is 7, b is 8, c is -5. Remember there's a negative there. So you just literally write it. So negative b would become -8. B squared is obviously 8 squared minus 4 times a, which is 7, times c, don't forget that that is a negative, over 2 times 7. Okay, that's what you're going to type in to your calculator, obviously plus and then minus. The one thing to note, which I don't think will be a problem here because b is positive, is that sometimes the calculator, when you square negatives, it gives you a negative answer, which is incorrect. So if you, let's say you've got this question, you've typed it all in, and you ended up with it said math error, you know, it says, it just doesn't give you an answer, it says math error. The problem is something inside the square root. And it's basically, the problem is that the calculator thinks it's a negative, and you know that you can't square root a negative. That's why it comes back with math error. So if you do get that, go back and try and figure out the negatives here for yourself. I would work that out for yourself and then put it back in the calculator and it should work. In this case it's fine because we're only squaring a positive number, so there shouldn't be a problem. But if you're squaring a negative, I would recommend just not writing the negative because you know that it should be positive overall anyway. Hopefully that makes sense. But yeah, if you get a math error, it's because of that. It's because of the square root symbol. Okay, so that's for the plus. So they wanted it in terms of 3 significant figures. So the decimal 0.448 is 3 significant figures, but obviously the next number is going to round it up, isn't it? So 449. So one of them is x is 0.449. Obviously this 0 here doesn't count as a significant figure. And then go back, don't delete it all, just use your back arrow. And change that for minus. Because obviously quadratics, we always get 2 solutions. Okay, that's minus 1.59. Now that one for 3 significant figures is just the 1.59, isn't it? There. Now I think they do give you possible, like those are the exact answers, but they will allow for if you've rounded it incorrectly. I don't know why, considering they've asked you to round it a certain way, but they have said allow for incorrect rounding. You could have had 0.448, that would be fine. Or you could have had negative 1.6. They've allowed that as well, but technically these are the solutions. Okay, and part C. So Alex has to find the solutions of the quadratic equation 3k squared plus 10k minus 8 is equal to 0. Here is his working and answer. What mistake has Alex made? Normally in this case I try and just work it out myself and then compare my answers. Or you could, you know, try and pick up on the mistake directly. So as I said, normally we try to factorize in order to solve quadratics. That's what he's done here, so I'm going to also do that. That'd be 3k. Okay. We are multiplying to make minus 8. That means I need a plus and a minus. And we're adding to make 10. And obviously one of them would be multiplied by 3. I normally just use trial and error because it's the number 3 isn't that big, but you could also use split in the middle term if you like. So we should get 3k minus 2, 4k plus 4. And therefore, if I solve it, I would get positive 2/3 minus 4. Now, compare that to his. He's got the second bracket. He's got the brackets right. He's factorized it correctly, so that's fine. But then when he solved it, he's got minus 4, but you see how this one, that's the problem. So you basically just need to reference that. Sometimes I find it hard to explain what's wrong, so I just kind of correct it and I say what it should be. So I'd say it should be k is 2/3, not whatever he put, which was k is 2. I think they allowed for, if you said he hasn't considered the 3, you could even just literally write that. When it's a worded question, they're not asking for something very obvious. Like, they're not asking something very, like a full analysis. They just want something really basic, like the most obvious thing you can write. So you don't have to even write a full sentence. So, yeah, he hasn't divided by 3, or he hasn't solved this bracket correctly, or whatever it is. That's fine. Okay. Plans are sometimes confusing. Yeah. Plans and elevations. I feel like that doesn't come up very... I don't know if you're doing... I'm assuming you're doing Edexcel, but plans and elevations doesn't come up often anyway. Like, it doesn't come up every time. So it's not the worst topic to worry about in that sense. Obviously, you want to be okay if it does come up. But it's definitely not one that... Yeah, it's definitely not one that comes up all the time. Like, there's obviously topics that will come up every single year, right? They're, like, guaranteed. And then there's some topics that don't always come up. Okay, you're saying if it's recently not... Well, I don't know if it's not recent. It might have come up last year, for example, and then not for another 3 years. I don't know. I've not really looked through it. But it doesn't come up all the time. It's like... Yeah, it's like a very small part of the syllabus. But yeah, that one... Yeah, it is kind of confusing, isn't it? It's not on this paper. Obviously, they would have asked it towards the start or middle of the paper. Obviously, we're beyond that now, so it's not come up on this paper. All the other 2 this week, or I think even the ones I did last week. So out of 6 papers so far, it hasn't come up. But yeah, it depends. Yeah, you'd have to try and find a paper where it has come up, and we can have a look at that paper specifically. Because I haven't got videos directly on plans and elevations yet. But yeah, it's not something I would like super stress over, because it doesn't always come up, right? Where it has both bearings and trig. I'm pretty sure I have. I know what you mean. It's like yeah, it's quite a hard one, and you have to use like sine or cosine rule, isn't it? I've got an actual past paper question video. I think that's uploaded literally this week. Let me check. I did a video, and it was obviously Edexcel as well, because I'm focusing on that. I did a video on the hardest Edexcel trigonometry exam questions. There's one question in there. Might even be the first question. Oh, it literally uploaded yesterday. That's the video. Yeah. It says it's called Hardest Trigonometry Exam Questions. And I'm pretty sure it's the first question in that one. But I know exactly what you mean. It's bearings, but then you create triangles, and then, yeah. Yeah, so I've got that. I don't know if I did it. I don't know if I made up my own, because I've got obviously videos separately on sine and cosine rule. Yeah, have a look at that. It literally uploaded yesterday. I think it's the first question. But yeah, that would probably come up more often than plans and elevations anyway. Bearings doesn't even always come up either, but when it does, it could be that one, which is obviously quite a hard one. So that one's probably more risky. It's good to know how to do it. But yeah, check that one out after the live. And I think you'll find it in the first or second question. Okay, so question 18. Enlarge triangle P by scale factor -1.5 with center enlargement -2, -1. So obviously make sure you mark that out correctly. -2 across, -1 down. So that's there. Check the scales as well. Now there's 2 things here. Obviously it's going to be enlarged by 1.5, so it's going to get bigger by 50%. But the negative means it's going to be inverted. So it's going to be like down here somewhere. So not only is it going to be bigger, it's also going to be further away from that center, and it's going to be inverted. So that's why it's question 18. The way I do it is I count it. Some people like to draw the lines, which is fine. I prefer to count it. It's, again, a lot of this is like up to personal preference. Whichever method makes more sense to you. It might be different to what I use, that's fine. So what I do is always counting from the center of enlargement to the corners. So for example, here we've got 1, 2, 3, 4. 4 to the left, and then I'm going to go to this corner here, so 1, 2 up. So not only do I need to multiply those two numbers by 1.5, but I also need to go the exact opposite direction. So instead of left, I'm going to go right. Instead of up, I'm going to go down. So 4 times 1.5 is actually 6. So that would be 1, and from the center, 1, 2, 3, 4, 5, 6. And then 2 times by 1.5 is 3. Instead of going up, I'm going down. 1, 2, 3. So that corner is now here. I mean, once you've plotted out the first corner, it's not so bad. Because let's say this second corner here is 4, 5, 6 across, and 2 up again. So 6 times 1.5 is 9. I know that that's 6, 7, 8, 9. Or you could just obviously count that that's 2 squares big, and then therefore it's 3 across. 3 down here. And then this one, it's obviously in line with this one, isn't it? 1, 2, 3 up, 4 up, which is 6. So 6 down, 1, 2, 3, 4, 5, 6. There. That's how I do it. Now you might want to use the lines. That's also fine. It just depends what you prefer. Obviously join it up. I think it said to label it, didn't it? Label it Q. There. Label it Q. When I say lines, what I mean is some people draw like from this corner and then through the center, and then you just extend it. And then that corner through the center. And you can kind of see roughly where it would map out, but you'd have to know the scale, I guess. That's the bit that I don't necessarily like. And then you would join it up, but you could do it that way as well. I just prefer to count. That's part A. Part B, triangle P, so the original, is transformed by combining, by a combined transformation of a rotation of 90 degrees anti-clockwise about the origin, followed by a translation to give triangle R. Exactly one vertex of triangle P, so one corner, is invariant under the combined transformation, so that means it doesn't move. Okay, one of the corners stays where it is. Find one possible column vector for the translation. They're saying one possible one because I think there's 3 possible ones, but as long as you get one of those answers, it's fine. Let's come back here. We're looking at the original, okay, not the new one, the original. So what I would do is probably plot out that rotation. Now, in the exam, you should have tracing paper. I obviously don't have digital tracing paper, but you would use your tracing paper, right? It says rotation about the origin, which is obviously here. So you would put your tracing paper over it, draw it, put your pen on the origin and rotate it in the correct direction. The way that I do it without tracing paper is from the origin. I go, well, it's like 6 to the left, so 90 degrees anti-clockwise, obviously that direction. Instead of to the left would be down. So that's 6 down, and then it's 1, it was 1 up, so that's 1 here. So that would be there. That's how I do it. Obviously you should have tracing paper so you don't have to worry. That's that first corner, and then the other one was 8 across, so that's 8 down and 1, so that's here. And then the other one was 8 across, and what's that? 1, 2, 3, 4, 5, 6, 7 up. So that would be 8 down and then 7 across. So that should be -5 there. I think I counted from here. 8 across and then 1, 2, 3, 4, 5. That's better. 5 across. Yeah. So that's where the interim triangle is, right? Once you've rotated it, you should get this. And then they've said they've translated it. That means moving it up and down, left and right, to the point where one of the corners wouldn't have moved. So you can just pick a corner. I think I picked this one. Did I pick that one? Yeah, you could pick that one. I mean, you could pick any of them, right? That one was the same as this one, wasn't it? So how far would I have to move the triangle left and right, up and down, to get back to up here? So can you see how I'd have to go 1, 2, 3 to the left? Now the top number is left and right. Left is obviously negative. And then that would be here, and then what's that minus 8? So 8, 9, 10, 11, 12, 13. Up, which is positive. Now, obviously that's my answer. If you'd picked any of the other two corners, you could have got minus 5, 7 or minus 7, 9. As long as you got one of those three, then that's fine. Okay, I just went with the one. I don't know, I just felt like going with that corner. Okay, bit of an odd question, that one, but anyway, it's only 1 mark. Okay, question 19. We've got, obviously, the diagram above shows a frustum F of a cone. A frustum is made by removing a cone with height 10. So this is 10. This one. From a solid cone with height 15. Obviously, if you add that, that makes 15. So a frustum is basically a cone with the top chopped off. That's basically what it is. They've obviously turned it upside down. They've then said, yeah, and the base diameter, done that deliberately, diameter is 24, so probably immediately I'd write the radius, because you know how all of these formulas are in terms of the radius. Otherwise, you might forget. So that's obviously half. Okay. The solid S is made by removing F from a solid hemisphere, as shown, and they've said that the hemisphere also has a diameter of 24, which is therefore also a radius of 12. I just like to annotate it whilst I'm going through the words. Calculate the volume of solid S. Okay. It's not really too complicated, it's just a lot of work and a lot of details to make sure that we don't mess anything up. And I'm pretty sure it was only 4 marks actually. Yeah. 4 marks. They do give you the rest of this page and the like half of the next page as well for space. So what we need to do first is obviously work out the volume of the frustum. In order to do that, we need to work out the volume of the big cone with these dashed lines, and then the volume of the little cone on top and take them away. So I'm going to start up here actually. The volume of the big cone, there. Now they're giving you obviously the formula, you don't need to memorize that, they will give it to you because it's not a prism. Is the third pi, now this is where it's saying r squared, so that's 12 squared times by the height of the big cone was 15, wasn't it? So obviously I can just type that in my calculator. 1/3 times pi times 12 squared, you could probably work that out to be fair, times 15. Now, see how it's giving it to you in pi? Yes, it's a scale factor. Yeah, I think if you don't know how to do that, if you don't know to do that, it's almost impossible. But yeah, once you know it's a scale factor, then it's fine. So I would leave it in terms of pi. I know it's got a decimal, but I wouldn't. Just, we're so far from the end. I would try and leave everything in terms of pi if you can. So that's 720 pi centimeters cubed. Then we want to know the volume of the small cone, which is what you're saying about a scale factor, because I need to know, I obviously know the height is 10, but I need to know the radius. And because, I mean, the cones are similar, aren't they? Mathematically similar. It's like the small one was just kind of dragged a bit bigger to make the big cone. They are similar. So, as you said, you need to work out scale factor, and the way you do that is by which side or which measurement do we have for both cones. Well, that's obviously the height. So the only thing is that I know they put 5 there. Obviously the whole thing is 15. That's what you've got to use, not the 5, because the 5 doesn't relate to a cone, it relates to a frustum. So you can divide them, as I said before in the other question, whichever way around you like. Doesn't really matter. I think I did the small divided by the big, but it doesn't really matter. So the scale factor is either 10 over 15 or 15 over 10, whichever way around. Because I've done it that way round, and I'm trying to work out the smaller like the smaller radius, I need to multiply it, because obviously that is a number smaller than 1, isn't it? So it's going to make my answer smaller. So I multiply it. If you did 15 over 10, you would then divide. Obviously the other way around. So it doesn't really matter which way around you do it, as long as you obviously then follow it up with the correct calculation. Your answer should be smaller than 12. I'm pretty sure that gives you 8. So I don't know if you got the radius as 8. That's what it should be. Because it's 2/3 effectively the size of the bigger cone, isn't it? So we've got radius 8, that's for the small cone. Now we know the height is 10, the radius is 8, so now I can work out the volume of the small cone. I like to label it just because when I go back I don't forget what everything is. So same formula, 3rd pi, radius is 8 squared times by 10. Again, just type that all in. Just going to go back and change this. Times 8 squared times 10. I know this one's kind of annoying because it's like a fraction, but I would still leave it like that. I still wouldn't write down the decimals. So 640 over 3 pi is the small cone. So therefore, we've got to try and remember what we were doing in the first place. To work out the volume of the frustrum, I just need to subtract those two, don't I? Volume of the frustrum is 720 pi minus 640 over 3 pi. That's much easier than using the decimals, isn't it? So my answer is still there, so I'm just going to copy the answer. 720 pi minus answer. Make sure obviously your previous answer is correct if you're doing that. Again, put it in terms of pi because we're still not at the end. 1520 over 3 pi. Okay, so that's the volume of the frustrum. Now we can move on from this. We're now on to the hemisphere. So, I don't want to scroll it too far because we need that formula, don't we? Again, a sphere, hemisphere, not a prism. You don't need to know those formulas, they will give it to you. So volume of a sphere, that's the only thing to bear in mind is they won't give you the volume of a hemisphere. They will give you the volume of the sphere. So obviously a hemisphere is half, so you need to remember when you're doing that formula to also half your answer. The volume, let me see if I can draw a hemisphere. Oh, that's a horrible hemisphere. Hemisphere, hopefully you know what I'm talking about there, is 4/3 pi. Again, remember it's the radius, which is 12 cubed, but you need to half that because that would give you the whole sphere. So while it's not hard, it's just all of these little details that we need to remember to do. That's, I think, the hardest bit. 4/3 times pi times 12 cubed. There's no cubed, okay. And then half that. (1,152 pi). Again, leave it in terms of pi. We're still not at the end yet. Now we're on the final bit. So the volume of solid S, they've called it S, the volume of solid S is the hemisphere, which is 1,152 pi, minus the frustrum, which was this one, 1,520 over 3 pi. So I'm just going to use my answer. Answer minus 1,520, right? Yeah, over 3 pi. And you get this now. This is actually the final answer, isn't it? So now I'm going to look at it as decimal. They said, give your answer correct to 3 significant figures. So convert it from pi into a decimal. 3 significant figures, 2002, but then the 2020, but then the 7 rounds it up, doesn't it? So I would put 2030. So you see how I left it until right at the end to actually convert it into decimals, so I didn't round anything too soon. Now they have said that they will accept anything between 2026 and 2030, which again wouldn't be rounded correctly. If you just wrote down 2027, then technically that's not rounded correctly, but they will accept it. So I don't know. I guess you don't have to worry about the rounding too much. But yeah, it's just a lot to go through, and I would make sure you just label it so you know exactly what everything is. And obviously, with cones and frustrums, you can use a scale factor because they are similar. So that's the only way you can work out the radius of the small cone. But yeah, as you can see, the next page, I've obviously done it on one page, but they've given you all this space as well. It's only 4 marks. I feel like it should have been 5 at least, but anyway. That's that one. GCSE, what I don't know if you mean if it stands for. It stands for General Certificate of Secondary Education. It's basically, I don't know if you're asking what it stands for, or if you just don't know what it actually is generally. Generally, they're just sets of exams in all the different subjects across. I don't know if it's the UK or just like England. I think maybe Wales and Scotland, Northern Ireland do slightly different things possibly, but definitely England. So yeah, you do them when you're about 15 or 16, if you are someone who doesn't have the context. Okay, 20, we're getting there. How many have we got? 20, 21, 22. Oh, we've still got like 5 left. Okay. Alright, that's fine. So the turning point of the graph of y equals g of x has coordinates -3, 6, which you can see here. Oh no, that's a different one, isn't it? They've drawn f of x, which you can't see there. Ignore what I'm just saying. So g of x, turning point of the graph has coordinates -3, 6, which we cannot see on the graph. Ignore the graph below. Write down the coordinates of the turning point of the graph of y equals g of x -7 in brackets. So this is graph transformations. So you just have to memorize the transformations, like memorize what they are. They've obviously used g instead of f. That doesn't make any difference. Don't worry about that. So what is this? This is a translation, first of all. I go through, is it translation, reflection, enlargement? It's translation because we've got a plus or a minus number. It's next to the x, so it's in the x-axis, but the x-axis is always something that's wrong, as in my head, so there's always something that's the wrong way around. So when it says -7, it actually means +7. And if it said +7, it would actually mean -7. That's only for the x-axis. The y-axis is the same, the correct direction. So it's only going to affect the x coordinates, right? The y is still going to be the same, so you could put 6. So then you just go, well, we're starting at -3, I'm adding 7, so that would be 4. Like, that's literally it. You just have to kind of try and translate what it's asking and then apply it to the coordinates, or whichever coordinate it's affecting, which was just the x. The graph of y equals f of x, okay, this is now a different one, is shown on the grid. On the grid, sketch the graph of y equals f of -x, and then outside the brackets +3. So that's 2 different transformations. So first of all, when it's just a negative, there's no number, that means a reflection. This is the one that's the wrong way around as well. It's next to the x, so it means that it's going to be affecting the x coordinates, which means it's a reflection in the y-axis. That's the one that's quite tricky. All of your x coordinates will either become negative or positive. And then, because it's a reflection in the y-axis, if you think about it, if I change all of my x coordinates here, they would go like over there, wouldn't they? Like here somewhere, to see how the reflection is actually the y-axis. So that was a bit complicated to understand. And then the next one, +3, is a translation. Because it's outside the brackets, that means y-axis, and the y-axis is normally the right way round, so that is what you'd imagine it to be. Go up by 3. Yeah, don't worry about this. See if you can do it. I mean, obviously they get harder as we go through, right? All the questions are going to get harder, so just see what you have been through yet and what you haven't. Okay, so it's 2 transformations. What you can do, I normally do like one of them and then like do a little map out on my pencil and then apply the second transformation after that. It doesn't matter which order you do it in. I tend to do it in the order that it's written, but it doesn't really matter technically. So, reflection in the y-axis. All I do is, because it says a sketch, is I just choose a couple of points that are pretty exact. So obviously this one would reflect here, wouldn't it? And then what else can I get? The ones crossing the x-axis, those are exact. So -5 becomes +5, +1 becomes -1, and then probably these 2 down here. So this is -6, so that would be +6, 2, -2. So that's the reflection, right? but I also need to move it up by 3. So each of these I'm then going to go, well, that was here at 3, it's now going to go to 6. Maybe let me do it in a different colour so you can see. And let me get rid of that, yeah. This one was at 0, so that's now at 3. Same with this one, 3. This one was at -7, so -4. And same here. Might plot these ones as well, to be fair. So that was -4, which would go to +4 and then up by 3. There, and then this one was on the mirror line, so it would stay the same, and then it would go up by 3. Okay. What about the one in the middle? Because I obviously want them to mark my final answer. And then obviously you just try and join it up in the same shape that they've got. It's kind of hard. Kind of hard to do it digitally, but in real life you should be doing a much better job than I can here. And down. Oh, yeah, that was really bad. You know, your version will be a lot better than mine, but you get the point. Okay, so that was just 2 transformations in one. Question 21, A, B, C, and D are points on the circumference of a circle centre O. AC is the diameter of the circle. ADE and BCE are straight lines. Work out the size of angle BDC. ADE and BCE are straight lines. They are not tangents, so don't get confused with that. This is obviously circle theorems. Write down any circle theorems you use. So just circle theorems, not all of your angles. Size of angle BDC. So this one we want. So what I did with this was, I mean, they won't give you information you don't need. So we need to use the 35 and we need to use the 28, right? So that's kind of, I feel like that helps me when I do circle theorems. So 35, what can that tell me? The one that, I mean, there's loads of different ways to do it actually. Circle theorems you can normally do in multiple different ways, but the way that I found was 35. There's kind of this bow tie. I don't know if you know it as a bow tie, or the official wording is the angles in the same segment are equal. 35 is the same as this one. That's what the 35 is telling me. So I would write down here, you can also label it, but I would write down here D, BC, or CBD, whichever one you want, is 35. Now they said write down any circle theorems you use. I'm pretty sure it's only 1 mark though. At the end, the answer 35 at the end is not 35, no. I mean, it's not far off, but it's not 35 at the end. Or you mean the answer to this bit's 35 then, in which case, yeah, that bit's 35. Yeah, so you'd write angles in, you don't have to write a full sentence, but they do want specific words normally. Oh, equal. When I looked at the mark scheme, because this is 4 marks, it was like 3 marks for the working, 1 mark for the circle theorems. Now I technically used 2, but I think you'd get a mark for just writing 1, to be honest. So I got that, and then what were we saying here? You said semicircle 1 to get ACD. ACD. Yeah, the semicircle would give you ADC, would be 90. If that's what you mean, because... Oh no, the final answer's not 35, by the way. To get ACD, yeah. Yeah, you could work out, like, from that triangle, you could work out this one. It depends where you're going to go after that. What I was going to say is that because of the semicircle one, as you said, this is 90, isn't it, there? And because ADE is a straight line, then obviously that one has to be 90, doesn't it? As well. And so if we just look at the highlight it, the big triangle BDE, this triangle. Do you see how we know that's 35? We know that's 28, and then we know different colour again. Orange. We know this angle is 90 plus the one we want. So that's how I was going to do it. Now, on the mark scheme, there are multiple ways to do it. Okay, so if you didn't do it this way, there's, you know, different ways to do it. It's not just only one way. So what I would say is BDE, the whole of that angle, is 180 minus 35 plus 28. That's just angles in a triangle, so I don't think I need to write down a reason for that because they said mention circle theorems. That's not a circle theorem, so I didn't write that one down. And then I just wrote down here, I think, just to really kind of over explain, CDE is the same as CDA, which is 90. And then I did use a circle theorem there, right? So I put angles in semicircle is 90. Again, I'm not even using full sentences, to be honest. Yeah, so since the angles in triangle, yeah, so that exactly, so BDE is 117, yeah. But because I know that a small section of it is 90 plus the one I want, so then my last thing was, we want BDC, don't we? BDC must be 117 minus the other 90, which gives you 27. So the actual answer is, like the final answer is 27. That's what I did. As I said, there are different ways to do it, so you might have used different circle theorems, that's fine. As long as you got 27 at the end, then it should be correct. Okay. Okay, this is the one on bounds. If you were looking for bounds, this is the one that is on upper and lower bounds. 4 marks. So Ebony makes some bracelets to sell. The materials to make all the bracelets cost £190, correct to the nearest £5, which is why I know immediately that it's upper and lower bounds. Ebony sells all the bracelets for a total of £875, correct to the nearest £5 as well. The total time taken to make and sell all these bracelets was 72 hours, correct to the nearest hour. Ebony uses this method to calculate her hourly rate of pay. So we've got obviously the price minus the cost, which is the profit, over the time taken. The minimum hourly rate of pay for someone of Ebony's age is $8.20. By considering bounds, determine if Ebony's hourly pay was definitely more than $8.20. Okay. So when you've got a calculation, like a formula, if you can still see, I've just moved it up. Yeah, exactly. So it could be a little bit less or it could be a little bit more. Yeah, so when you've got a formula, so here they've given us formula, we've got 3 different things to input. You have to work out the upper and lower bounds of each of the original parts, if that makes sense, and then use the formula after. So the way you might be able to just work out straight away, but I like to kind of lay it out like this. So what was it? 190, then I do whatever it's rounded to above, so 195, and then one of those below, so 185, and then the upper and lower bounds are halfway. That's kind of how I visualize it. You might be able to just do it without. That's fine. Lower bound, upper bound. So obviously that's 87.5. That's 192.5. So that was the cost. Then, same again, but 875. One lot of 5 above is 880. One lot of 5 below is 870. So halfway. Ooh. Is 872. Right, so you can read it. 0.5 for the lower bound. 877.5. Basically half of whatever they've rounded it to, if you don't want to draw it all out like this. The upper bound. And then the last one, obviously the time as well, 72 hours. Now they said correct to the nearest hour, so 1 hour above is 73, 1 hour below 71, so obviously then it's halfway. That's what I do. I find that works for most types of rounding. It's quite a consistent method to use. Some of them are obvious and some of them are less obvious. Just depends. Okay, upper bound. Yeah, so I've done that. Yeah, so lower bound is 190 minus. Yeah, exactly. Selling price. Yeah, exactly. Yeah, you're right. That's fine. So I worked those out. Now, this is the thing that actually threw me on this one because it says by considering bounds. Normally, when it says by considering bounds, you have to work out the both the upper and the lower bound for whatever this is. In this case, it's the hourly rate of pay. And then at the end, you compare your answers. But when I looked at the mark scheme, they actually only used one of them. So I guess the context, we want to make sure that her rate of pay in the best case scenario, but also the worst case scenario, is still more than 820. So in this case, as long as we can work out the worst case scenario, if we can work out the worst case scenario and that's still more than 820, then we can guarantee that the best case scenario is obviously more, isn't it? So in this case, they only worked out one. The worst case scenario would be the lower bound of the pay, wouldn't it? The lowest amount of pay. So yeah, so we'll get on to that. So then you have to work out which combination of upper and lower bounds you need. Yeah, you have to, when you've got, it depends on the formula. If you've got multiply and add, then it's either both positive or both negative to get the biggest or smallest answer. When it's subtract and divide, which unfortunately is here for both, it's like normally one of each to get the biggest answer or to get the smallest answer. We want to get the smallest answer for the hourly rate of pay, right? So the lower bound of the pay is what I'll write here. In order to get the smallest answer, just think about your calculation. To get the smallest possible outcome, I want to divide the smallest number by the biggest number, don't I? So the least amount of money by the most amount of time. So that means I need the upper bound for the time or the hours. And then at the top, I need the lower bound. This is profit, isn't it? The price minus the cost is profit. The lower bound of the profit. So how do I get the smallest possible profit when I subtract? Well, I need to take the smallest price. So I need the lower bound of the price minus the biggest possible cost. So you see how I figured out which ones I need? It's like a combination. Again, this is why I guess it's almost at the end of the paper. And then all I need to do is input those, right? So lower bound of the price, I think we got it the wrong way around, haven't we? So the lower bound of the price is the 872.5, and then the upper bound of the cost, 192.5, over the upper bound of the hours. That's what I would type in. I don't know if that's what you'd said, Sean. So yeah, you divided by 72.5, didn't you? That seems right. So 872.5, 0.5 ideally, minus 192.5 over 72.5. I just worked out directly. Well, that's a horrible number, but anyway. You should get, Sean, I don't know if you ended up yeah, you got 9.93. Oh, that's the upper bound then. That's the other one, I think. Well, that's, no, that wouldn't be quite right. No, I think you mixed that up. You've got the denominator right, but the 720's not. In the numerator. So this is the smallest possible hourly rate, which, because it's money, I would round it to 2 decimal places, but they don't really, again, they're not really that bothered by the rounding. So 9.38 is what I'd round it to. Now, if that's the worst case scenario, isn't it? That's the worst case. That's still more than 820. So the best case, like if you were to work out, you were close. If you were to work out the upper bound of the pay, it would obviously be more than 938, wouldn't it? Because that's the upper bound. So that's obviously implied it's more than 820. So in this case, you actually didn't need to work out both. I think when I did it originally, I did work out both, just because it told me by considering bounds. And if you're just interested, the upper bound is £9.65, which is obviously more, so more than 820. I think you also had to do, because it said show, or determine if it's definitely more. Well, that's the worst case scenario. So I think you write something like £9.38 is obviously more than 820. I think that's just a conclusion. But it's just this bit trying to figure out which ones you need, which upper and lower bounds you need in order to get your answer. Yeah. Just takes a bit of thinking through, really. Okay, 2 more. So, Question 23. Given that 2x squared plus y squared over 4x squared minus y squared equals 43 over 11, where x and y are positive, find in its simplified term the ratio x to y. So, this is one I think I didn't actually know. Do you get method marks for using the wrong one but doing the right method? Oh, I see what you're saying. Let me check. Let me check the mark scheme before we move on. Because, yeah, I don't think they penalise you 100%, but... Let me get the mark scheme up. November 23, paper 3. Here, I think you can see this, can you? What was it, question 22? There. You see that they've only given this one 937 or 938 rounds up to. So you get 1 mark for stating at least one bound. So any of these, only one of them. So you're obviously going to get 1 mark. For the correct use of lower bound and upper bound to find the lower bound of the profit. Yeah, they've specifically said the correct use of the lower and upper bound, i.e. the lower bound minus the upper bound, in that order. The 3rd mark is depending on this one, I guess it says. For correct use of the lower bound and upper bound to find the lower bound of the... Yeah. Oh, that's annoying. I think you'd only get 1 mark then. Yeah, that's actually... I'm surprised. Normally they kind of... Yeah, normally they're not that bothered, are they? I would have thought you would have got 2 marks. Obviously not the final mark, because you won't have the right number. Yeah. Yeah, that's annoying, actually, isn't it? Yeah, no, these questions are really... But this is... Well, this is the end of the paper, right? Grade. Upper bounds. What would I call it? I'd probably call it a grade 8 upper bounds. Out of 9. This type of question is up there. You can also see the answer to the next one. But anyway, yeah, this is a really hard question, that one. You just have to, as long as you can get your head around which combination of upper and lower bounds, just think about it. Think about calculations, like, if you need to get the smallest answer, just think about it. Like, what do I need to subtract? What do I need to divide? It is hard, but yeah, just try and kind of figure out how you'd get a smallest answer or how you get the biggest outcome or whatever you're looking for. Okay. This one, I feel like I didn't know this when I was in GCSE. I feel like I wasn't told this. Sean, I don't know if you're, like, are you from the UK or are you from the US and you mean grade as in age group? It's not like year 7, year 8, it's like UK grade. Do you know what? I thought that as well when I first saw it. Yeah, I saw that, but I did it a different way without having to do that. But I did see that. Oh, okay. No, okay, so Sean, it's not as in year. You're not like age. Whatever age you are, you're in grade 7, 8. It's not that. This is, I don't know how your grades work. This is like just before high school, I guess. I don't know how long your high school is. Our high school is 2 years. This is the year before that. So you're like age 15. Most people I think are 16, but some of them are still 15. If that gives you an idea. But this is like the top end of that. Well, we call it secondary school because we don't have middle school, high school. But whatever age, yeah, whenever you're 15 or 16 years old. Okay, yeah. I don't know I like sophomore, I don't really know what any of that is, but yeah, whatever year you're in when you're 15 or 16, basically. But this is like the top end, if that makes sense. This is like one of the highest levels of that age group. So it's not like this is a widely understood topic. It's not like everyone just understands it, right? This is like the top end of age 15, 16. Because we've got 1 or 2 more questions left, that's it. So yeah, Yeah, I also saw the difference of two squares, but then I was like, I don't know if that's really helpful. So I just didn't do that. Like, the way that we can convert between ratios and equations, and this is the bit that I don't think I knew this when I was at school, but you can do this. X to Y, if you were to put it, and obviously you'd then have numbers, right? You'd have one with numbers. I'll put A and B, but these are meant to represent numbers, right? To put it into an equation, you can either swap them around, so what that means is B times X is the same as A times Y, or you could do X divided by Y is the same as A divided by B. So that's how you can convert, like if you've got, yeah, exactly, that's what I would do, I would cross multiply. We want to rearrange this equation to get either of these. Well, that's meant to be an equals, isn't it? Hang on. So where's my other equation? AY, there we go. Either of those two formats of the equation. So I would cross multiply. You can cancel out the what? No, you can't cancel out the y squared. Just because when it's a fraction, you can only cancel out terms if they're in all four. Like in this case, you see how it's 4. If I had y squared in all of them, then I would cancel it out. But it's not. It's only in 2, so I can't like cancel it, if that makes sense. So yeah, I would cross multiply. So multiply the denominators. So you get 11. You can obviously expand it directly if you want. But I'm just gonna write it out fully. And then 43 times the other one. Get rid of the fraction, because that's the annoying bit, isn't it? Okay, obviously then I would expand. Oh, like, elimination. Yeah, if it was in a completely different format, you could, but in the fraction, you can't just cancel them, just because one's plus, one's minus. If they were two separate equations, then yeah. Or I guess, yeah, if you're putting them equal, like as in the numerators are equal and then the denominators are equal, and then you add them. But then that would get rid of, yeah, that would get rid of the y, wouldn't it? Yeah, maybe that would work. I haven't tried it that way. Yeah, so expand it, 22 x squared plus 11 y squared is a 43. We have to times that by 4, which I'm pretty sure was 172. Oh, I'm not from the US, so I wouldn't know what that is, to be fair. 172 x squared minus 43y squared. I want to get the x's and the y's together. Ideally positively, so I moved the y to the left and the x to the right, just to keep them positive. That gave me 54 y squared and 150x. Oh, that's a horrible x. So I just basically took away 22x squared and added 43y squared. And then, I mean, you could probably simplify that, but I basically just square rooted both sides. And if you put that in the calculator, like 54 square root, where's my square root calculator? 54, what is it on it? Type. Is 3 root 6. I just don't write it as a decimal, I write it like that. And then if you square root, because obviously you're square rooted on both sides, right? Do you see that's also something root 6? We've got 5 root 6 x. So I square rooted. And then because it's an equation, I could cancel out the root 6, because if I divide by root 6 on both sides, it would disappear. So do you see how that leaves me with 3y equals 5x, which, if we come back to the original things I said, is a very similar format to that. So then from here, I would just memorize, oh yeah, I just need to swap them. So like x to y would be 3 to 5. You just have to swap them over if it's in that format. 3 to 5. But I didn't necessarily know this bit when I was in school. I don't know if you've ever seen that before. I didn't know this myself, but now I do. So yeah, if you just memorize that kind of mathematical fact, that might help. But if not, you could always get to this point, and we should check the mark scheme how many marks you'd get for just getting to that point. Yeah, you get 3 out of 4 if you'd rearrange the whole equation to get like a simplified version of x and y, you'd get 3 out of 4. So even if you didn't know how to make the ratio, that's still 3 out of 4, which is not bad. No, the ratio is the colon, this dotted, that's the ratio. The equal signs are equations, and they've just asked us to convert between an equation and a ratio, which is this relationship up here. Okay, last question. The diagram shows a triangular prism with a horizontal rectangular base ABCD. M is the midpoint of AD. The vertex T of the prism is directly above M, just so you know it's not like slanted or anything. Then we've been given this information, which they haven't labelled, so I'm going to label that. So 14.7, you try and write it clear enough. 14.7 is that one, and obviously then CD as well. BC is 3.8, which means this one is also 3.8 because it's a rectangle. And then MT is 2.3. It's kind of hard to label it without covering everything up. P is the point on AB such that AP to PB is 5 to 2. So I'm just going to roughly draw that on. So like it's probably somewhere over here, isn't it? That's P. Okay. Calculate the size of the angle between TP, so draw TP, and the base ABCD. So if you draw TP, draw any lines you feel like are helpful. You can always annotate it, it's fine. If it's going to let me draw a line, that'd be great. No. Oh, let me draw a line. That's so strange. Well, that's going to make it a lot more difficult, isn't it? Ah, okay, well, I'm going to have to try and draw it myself, which is not going to be very straight. See if I can use a ruler on my tablet. Oh, it's horrible. Okay, that's with my actual physical ruler, so let me move P. P doesn't really matter. Put P here. Okay, so that's TP. When they say the angle between a line, so this is TP, and then the base of any 3D shape, yeah, you have to create right angle triangles. So when they say, this actually happens quite a lot with Edexcel, it's between like some kind of diagonal line and then a base. It's kind of hard to figure out. It's not like this, right? It's not that. So what you have to do is draw another diagonal line across the base, but from obviously whichever points are relevant to you. To me, obviously P is relevant because it needs to be between TP. And then I need to create a right angle triangle, as you said. So that would be, I could do from M to P. This one's quite hard because I feel like it's not as obvious. Like normally they're a bit more obvious, I feel like. They're gonna try to line up my actual, my physical ruler with my tablet. 10. It's too high. Give me a few goes. No. Angle we need. Almost upwards actually, isn't it? Okay, that's way. It would be great if my actual pen tool worked, but yeah. Give me a second, guys. We just want to see it properly. Right, I'm gonna go with that. It's the closest I can get. For some reason, my line isn't working. Imagine that that's obviously touching at M, right? Just imagine I've actually drawn a proper triangle. What did you do? Because TAP. Oh, okay. Yeah, normally, yeah, it is a right angle. It's always a right angle triangle. This is 3D trig, isn't it? The topic is 3D trig. Now, 3D trig is still either Pythagoras or SOHCAHTOA, which is right angle triangles. But they're always right angle triangles within a shape. And normally, this one where it says angle between a line and a base, or sometimes they say the plane, which is the base anyway. It's normally a triangle. It's like stood up. Do you see how that's like? I know it's quite hard to see, but it's like literally stood up, right? Isn't it? It's not normally a diagonal triangle. Anyway, so this is obviously right angle there. We want to know that. Okay, we've got there in the end. So of that triangle TMP, we know the height here, or in the case of obviously trig is the opposite. We know 2.3. We need to know one other piece of information. And so it's either TP or MP. And you just figure out which one looks easier. In this case, I would suggest that MP is easier. MP. So that's when I would look at the triangle here. MAP. That's just flat on the base, isn't it? TAP is a right angle triangle. It is also, yeah. TAP would also be a right angle triangle because this side here is a... I'll get rid of this. Like, this is a right angle there, isn't it? Anyway, so we're looking at the one at the base. You can always rewrite or redraw. Well, apparently I can't right now, but normally, if you wanted to, you could, if it gets too complicated on the actual original diagram, just draw the actual just right angle triangle yourself and label it separately. You can do that. Anyway, so I know that the whole of AD is 3.8 and M is the midpoint, so that's obviously just half, isn't it? So you see how this one would be 1.9, that's fine. This one, A to P, is not 14.7. 14.7 is the whole thing. So that's when I would have to use this ratio. So we need to share out the ratio, which you normally add 7 parts, and then you would do 14.7 divided by 7 parts to find out one part. Calculator. Divided by 7 is 2.1. You sure? Yeah. 2.1. Now, the side that we want is AP, which is the bigger side. It's the 5 parts, isn't it? Yeah, divide by 7 times by 5, exactly. So 2.1, you could probably do that in one calculation rather than 2, which I think is 10.5. Once that times 5, you should get, I'm pretty sure, 10.5. Yeah, 10.5. Okay, so let me just rub out this 14 so we don't get confused. And now, I know it's called 3D trig, but... Yeah, exactly. I know it's called 3D trig, but actually you could use Pythagoras as well. In this case, I'm going to use Pythagoras because do you see how I've got 2 sides? And I want to find the third side. So that's, I think it's on your formula sheet, but you probably know what it is anyway. 1.9 squared plus 10.5 squared. C is always the hypotenuse, right? The side C, you know, it's a squared plus b squared equals c squared. A, b, c. C is always the hypotenuse, which is the one we want in this case. That's quite handy. Obviously, calculator. I'm going to square root it straight away. So that my 10.5 squared plus 1.9 squared, square root that, gives me MP. That doesn't look right. Maybe my answer was wrong. Be careful when you're using the answer button if your previous answer is not correct. Then it could obviously give you... There we go, that looks better. So yeah, double check. Yeah, exactly, 10.66. Yeah, double check. If you get an answer and you look at it and go, does that make sense? Like, to me, 50 doesn't make sense when one is almost 2 centimeters and one is 10. Like, I knew it couldn't be 50, so like, that's how I picked up on the fact that I'd made a mistake. So 10.67 ... I'm going to try not to lose all those decimals, but I'll just write down 10.67. So now I know this one. Now we can focus back on the original triangle, TMP, which is now trig, isn't it? Because I want to know an angle. So I label just 2 sides that are relevant, which is the opposite and the adjacent, because those are the 2 that I have. The hypotenuse is not relevant to me. So that means I need to use tan. because it's an angle, we've got tan. Let me just call this x. You can always label it x if you want to. Tan x is opposite divided by adjacent. So 2.3, you can't really see I've written that very well, but 2.3 divided by my 10.67, which I'm going to copy my answer in the calculator, but I'll just write down a couple of decimals there. Now, whenever we're finding an angle, we always have to do the inverse, don't we? As in tan to the -1. Otherwise, you won't get the right answer. So, I've got the correct thing there. So, shift tan, do you see how it gives you the -1, which is the inverse, because I'm looking for an angle? Then I would put 2.3, and I'd put my answer button so I could copy all the decimals, because I want to be as accurate as possible. Close the bracket. There. Oh, you haven't learned tan. It's sin, cos, and tan on your calculator. Can you see here the three of them? Sin, cos, tan. That's trigonometry. Yeah, SOHCAHTOA, exactly. I have videos on it if you want to go through them. Just look up trigonometry on my channel. Because it's quite a lot to kind of explain in like a couple of minutes. But it's basically where it's a way of working out either a side or an angle of a right angle triangle. It's like a method of working that out. So, what did I say? 12.163 ... Now we check what they rounded it to. They said round it to 1 decimal place. 12.2 degrees. That would be your answer, 4 marks. So yeah, this one's kind of complicated, but as long as you've seen it before, and I have seen this come up, normally in a more simpler way than this, to be fair, but where they want the angle between a straight line, like a line, and then a plane or a base, and it's always the same kind of drawing. So at least that's consistent. Obviously they could change it, but I've seen a pattern. So 12.2, and that is, as you can see, the end of the paper. 80 marks. That's paper 3. So you can always go back on my channel. I've got paper 2 and paper 1 from this November 2023. Those have already uploaded because I did it Monday and yesterday. So yeah, I don't know if you guys have any questions related. Obviously the formula sheet is here, by the way. This is the formula sheet you'll get. I'm a tutor. I'm not a teacher, but I have tutored maths for, I don't know, like almost 4 years. So yeah, not trained as a teacher specifically. But yeah, so this is your formula sheet. You can see obviously you get Pythagoras and sin, cos, and tan, and all the sine rule, cosine rule, all of that as well. So yeah, if you have any questions about this paper, obviously leave them down below. Go back and check out the other 2 if you want. Last week we did June 2023, all 3 papers. If you want to have a look at those. Next week, I think is June 2022. I'm just like working backwards basically. And obviously your paper 1 is coming up soon, so I think after next week, I think I plan to just do paper 1 past papers. So I think next week we'll do another week of just a whole, paper 1, paper 2, paper 3, and then after that it'll just be paper 1 from all the previous years until your first exam, and then we'll swap over back to paper 2 and paper 3 after that. So after this, I will go through and find the links for any videos that I've made on topics that have come up in this paper, and I will link them in the description. So yeah, if you want to look at that, give me like kind of half an hour to sort that out, and then you can come back and have a little look at those. Obviously, feel free to scroll through my channel anyway. See if there's any other videos that are helpful. And the past papers are the ones that are the live videos. Do I have DC? What is DC? Oh, if you give me a paper, well, as in a paper from the US. Oh, Discord, yeah. No, I don't have Discord, actually. I didn't know if it was that kind of thing that was on Discord. Or if you think it is, then I could look into that. I've only just started doing the lives, like, literally last week, so I'm definitely new to this. Live streaming, but I can look into it. But yeah, otherwise that was the whole paper. I mean, you obviously, I guess, won't know what this is, but if I go back and show you the front page. Yeah, I don't know. I thought Discord was just for like gaming, but I've not been on it, so I wouldn't know. But yeah, it might be a good idea. And channels for okay, yeah, that's interesting. I'm just gonna go back to the first, like the cover page, so you can see what it is. But yeah, these are the exams that the UK students who are 15, 16 will be taking next month. Less than a month, actually. This is one. They have to do 3 papers in like within 4 weeks, I think. Yeah, that's what it looks like. They have different. Edexcel is one version. There are different versions like AQA, other ones, depends what school, which exam board your school has chosen. Yeah, I think I'll have to have a look into it first and see what it is, and like kind of get an idea of what it is, and see if I can do, I don't know, like add stuff on there. That could be quite good. But yeah, thanks for mentioning it. I'll definitely have a look into it. Otherwise, everyone, this is basically everything for the paper 3. Always get a grade 8 close to a grade 9 for paper 1, but okay, that's interesting. I think there are harder. Well, I also think there's slightly harder topics on paper 2 and paper 3. Maybe that's just me, because it's calculator. That's technically it's kind of harder things they can do. Silly mistakes. Is it like you type it in? You know, like sometimes I type it in wrong to the calculator and write down the wrong number, or is it? Yeah, where are the silly mistakes coming from? Oh, that's interesting that it's only like not on paper 1. That's really interesting. Yeah, I don't know, just practice once you've done maybe the question, just double checking. That once you've done your working, maybe double checking the question. I guess in terms of the shape ones, it's just once you get a number, think, does that make sense as a number? I don't know, yeah. Okay, bye Sean. Yeah, I think maths, it's just a lot of practice as well. That's the thing. It's whether it's practice of the content or exam technique practice. That seems like it might be more exam technique. Yeah, maybe it's worth practicing the proofreading almost more than practicing the content. I've never done SATs actually, no. Because I'm from the UK, I don't know. Like, I'm vaguely aware of. Like, I've heard of SATs, but I couldn't tell you what it is. So no, I'm sorry. I literally only do UK papers. That's it. Whether the same content comes up, I don't know. You could look through my channel and have a look at my other videos, which are not on past papers. They're just like topic videos. Yeah, vectors. Yeah, vectors is the worst topic, I think, on the whole syllabus. That's for me. Yeah, I think it's the worst. The thing is, if you're aiming for an 8 or a 9, I don't know what you're aiming for, but that's still not 100%. Like, you're not aiming. I don't know if you've looked at the grade boundaries before for the previous years. I would recommend going through it and having a look, because it's a lot lower than I think you would think it is. Even to get a grade, like, you're not trying to get 95%. So if you can kind of almost get the marks somewhere else, then you can forfeit the marks on vector. For example, you can forfeit the marks on certain topics because you know that you'll get them somewhere else. There's that as a tactic. The other thing is I have put up videos on vectors proof, and it's normally one of 2 questions. If you're proving that it's parallel or a straight line, to be honest, that's really easy. I don't know if that's the one you had a problem with. That one's quite easy as long as you know what to do. So have a look at that video. The other one, which I think is the worst one, is when you're trying to find a ratio. Or trying to find a scale or something. So the ratio. So what I say for vectors, write down as many vectors as from the diagram that you can figure out, because normally that's half of the marks. Even if you don't do anything with it, just ignore what the question was asking, just write down any vectors from the diagram that you can figure out, because that bit's not normally that hard. But for the bit where it says find the ratio or find the scale, you know, like find k or whatever it is, there's actually a method that works every time. So even though it's hard and even though it's kind of long, it is a pattern. So that's a benefit. So I've also got a video on that. I can link it all down below. Which is, yeah, vectors ratio scale, I think I called it. And if you just go through a few questions, even though the shape is different and even though the question is slightly different, it's the same method every time. So you could just memorize the method. And if that comes up, then you just recite the method, because I've applied it to, I've seen it on past paper, like Edexcel particularly, I've seen that one come up so many times, and it is the same method, more or less. So there is hope. Oh, I don't think I do. On the equation of a tangent and to a circle. That's really easy though. As in, I mean, it is a higher grade, but it's easy because it's straight line graphs, which you already like technically know, but it's just applied. It's like perpendicular lines. Yeah, that's one that will probably always come up. But it's really nice because it's just perpendicular lines. So as long as you know how to find the equation of a perpendicular line, it's that, basically. You just have to find the gradient of the radius, because you don't have enough information about the tangent. So you find the gradient of the radius, then you do the negative reciprocal, which you know is the perpendicular thing, and then you carry on with the rest. So, because you know, if you think about circle theorems, radius and tangent are always 90 degrees, aren't they? Perpendicular. So it's just using that logic. And you should know that the center of a circle is always 0, 0. So you've got 0, 0 as a set of coordinates. They will give you the other set of coordinates where the tangent touches the circle. That's the two sets of coordinates to make a gradient. Oh, so not just find the equation of the tangent, but more than that. Yeah. Yeah, sometimes you have to use Pythagoras, isn't it? With these coordinates. If they've not drawn it for you, sometimes I draw myself a little sketch. I find that helps, even if it's not that accurate. But yeah, it's I feel like the equation of the tangent ones, it's either work out the equation of the tangent directly, which is straightforward, or it's, you know, one that's more complicated, like you said, but within that, somehow you have to find the equation of the tangent anyway. So yeah, it's getting... I just find, like, if you're not really sure what to do, I would just write down anything you think is relevant, even if you're not sure if that's what they're asking, because you just don't know where the method marks are coming from. And you could probably get a really good grade from just getting like 2/3 of every question right, you know, even if you didn't get an answer. So it's always worth writing down anything that you think's relevant. You say heart of algebra. Yeah, that sounds... I mean, we just call it algebra, I guess. Problem solving and data analysis. Yeah, I don't know if we have stats, but it's not like that deep because they're still kind of too young. Passport to advance. Why are they named like that? Additional topics in math. Okay, that could be anything, I guess. Oh yeah, because you guys work with inches and feet, isn't it? I would probably just draw a little square, just because I like to visualize things. That's my preference. Label both sides 0.417 feet. Yeah, and then you just times it together, which is squaring it. But then, how many square feet is 5 square inches? Oh, 5 square inches. Hang on. No, that's different, isn't it? No, I think you'd have to... It's throwing me off that it's in inches, but that's fine. Let me get my calculator. If 5 square inches is 0.417 feet, then how many square feet is 5? Oh, sorry, if 5 inches is, yeah, how many square feet would be 5 square inches? Yeah. I was thinking of doing it on TikTok, but my TikTok doesn't really reach the right location. If it's 5 square inches, I guess you'd have to square root the 5, would you? To get the sides, if you imagine of a square, which would be 2.236 ... loads of decimals in inches. I'm trying to write on a piece of paper, but it's probably better if I write it here. Imagine that's a square. Obviously, doesn't look like it. If that's 5 square inches as an area, then you'd have to square root it, wouldn't you? Which gives you 2.236. Obviously, loads of decimals, right? ... So that would mean each of the sides is that in inches, right? And then you want to convert it into feet, don't you? Or square feet. So I guess you would multiply each of these by 0. No, wait. That's 5 inches. Why is that such a weird question? I guess you'd have to 0.417 divided by 5 to get 1 inch in feet. 17 divided by 5. Yeah, I mean, we don't, to be fair, have questions like this normally. 3, 4. And then do you times both of those by that? I'm just guessing at this point, to be honest. I've not had a question like this before. So that same thing would be 0.01864 ... and that'd be 0.01864. And then what, you square that? 0.1233477. I mean, that's what I got. I'm probably wrong though. I don't know if that's even right. But yeah, it's a very different question to what we get. Is that what you class as problem solving, I guess? What was it? Problem solving and data analysis. I don't know if that's problem solving, but I have to look up the answer because I'm going to look up the answer because I feel like I could just be making this up. Five square inches in square feet. That was the question, wasn't it? Yeah. Oh. I've got the right digits. I just don't have the right scale. I've got the right numbers, but Google says, yeah, I was thinking that's problem solving. Google says it's this. So I've somehow got too many zeros, but the digits are correct. If 5 inches is that in feet, then how many square feet is 5 squares? Why is it worded like that? Because I took it as the area being 5, not the lengths being 5. That's how I interpreted the question. I don't know if I've interpreted it correctly. Yeah, the way it's worded is not clear, is it? 0.417 divided by 5 is 0.0. Oh, it's because I've written one too many zeros here. That's why I was wrong here. Just written it down wrong. Is that? So that's how many feet in 1 inch, one dimensional. So then I need to multiply those together. Let me rub this out because this is obviously not to the right scale. Yeah, I added a 0 for some reason. I don't know where I got that other 0 from. So then I would have done 2.236. Obviously that was a longer number than that. Inches times by 0.0834 to convert that into feet. Which gives you, this is still one dimensional at this point. There we go, now I think I might get the right thing. So each of these side lengths is 0.864 feet. And then you're trying to make it square, so you obviously multiply those together, or square them. There we go, now I've got it, yeah. I just wrote down one too many zeros. So when you square those, or you multiply them together, it's just because it's like it feels like a trick question. Like it feels like a riddle, if that makes sense. You know, it's like, how much wood could a woodchuck chuck if a woodchuck could chuck wood? Like, it's like that. That's what it sounds like to me. I don't know why. I don't know why it needs to, like, compared to what we have here, it's just write this, write that. Like, it's, do you see what I mean? Like, that's very clear. It's not like, if this was this, then what's that? You know, I feel like that's more complicated, but that's just the type of question you're used to in the US, and here we're used to, obviously, different wording. That's just the difference, isn't it? Yeah. Yeah. Oh, there's my rough working. I don't know if that makes any sense. Yeah, I like to visualize things, so I find it helpful to draw them. And I drew a square, because obviously they're saying square inches and square feet, so it's a square, right? I just drew it to visualize it. Really? Yeah, but I guess you're used to that type of question, isn't it? Because half of it is being used to the maths, and half of it's being used to the questions, like the wording. And obviously, over here, we don't have questions that are worded like that, basically. We just have calculate this or work out this. Like, it's kind of more straightforward. But yeah, you'd obviously grown up with that, so that makes sense to you guys, doesn't it? You kind of know exactly what they're asking. So it's as much getting used to maths as it is getting used to your types of questions, and that's why with these guys they have Edexcel as one of the exam boards. There's also AQA. There's also OCR, probably some others. And Edexcel and AQA are, even though it's the same maths, like the syllabus is the same, the way they word the questions is very different. So that's why it's important, if you're about to do your GCSEs in 1 month, you need to do your own exam board, not someone else's exam board. Otherwise you could lose marks just from not understanding the question, not because you didn't know how to do the maths. So that's as much of the revision, I would say, is understanding your own exam board. So yeah. Yeah, so you should get 0.03477. I'm assuming this was a calculator question, because I don't know how you do it without calculator, but yeah. Anyway, guys, I'm going to finish it there, so we will be back on Monday, 7 o'clock again. Monday, Wednesday, Thursday. Monday, Wednesday, Thursday, so paper 1, paper 2, paper 3.